Yo, 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 yo. Hey, everybody. So, we're going to get into factoring quadratics. So, let's just get right into it. Your key term right here is just factoring. We know what factoring is, but let's just get that down. So, what we want to do is we're going to factor quadratics. Now, we want to know how does factoring and trinomial relate to multiplying binomials. So if I go look at this right here I have two different binomials right now, okay? And with two binomials, if I were to multiply these with distributive property, it would give me x squared. Oh, that was weird. Oh, there we go. Okay, pen stopped working for a second. So that would give me x squared plus 3x plus 2x plus 6. Well, this simplifies to x squared plus 5x plus 6. So here I have a quadratic trinomial, and it's a quadratic. We call these quadratic because the degree is 2. But whenever we factor quadratics, they actually end up becoming two separate binomials. So quadratics are going to factor into two different binomials. And so what we want to do is, instead of multiplying from two binomials to get to a quadratic to here, I want to know, how do I get from here to here? How do I factor out a quadratic, and how do I figure out that it's going to be two different binomials with x plus 2 and x plus 3? So the way we do this is we are going to, here, I'll go to this one. So the way we do this is we are going to factor by finding a common, we're looking at what are the factors of 36 that add up to 13. Okay, so if I want to know my binomial, what I'm looking at all of x squared plus 13x plus 36. This is a quadratic, so I know it's going to factor into two binomials. So now what I want to do is I want to figure out, the way I figure out what my values are is I figure out what are the factors of 36 that when I add them, they equal 13. So if I start thinking about factors of 36, I know 6 times 6 is 36, right? But if 6 times 6 is 36, does 6 plus 6 equal 13? No. So then I got to figure out, okay, well, so that doesn't work, because I got to figure out factors of 36 that add up to 13. If I did 9 times 4, that's 36, and 9 plus 4 is 13. So that is why, so this 9 and 4 is going to be the values that I include in my binomial. So here's what I mean by that. I know that this is going to, yeah, the pen is just acting funny. Sorry guys, it's throwing me off. Like, sometimes it works, sometimes it doesn't work. Okay. So I know that this is going to separate into two binomials. And what I'm trying to figure out is what's the value that we're gonna add in both those binomials. Well, what I figured out is that they're 9 and 4. Okay, and the reason why is 9 times 4 is gonna give me that 36, that last term at the very end. Okay, and then what I also know is that if I add these together, because I'm gonna do 9 times x, and I'm also gonna do 4 times x, and those are gonna combine to 13x. So factoring this out, what I always want to do is, the way we figure this out is we figure out what two factors of the last term, we call this the C term, because in quadratics it's always A is the first one, B is the second one, C is the third one. So I'm trying to figure out which two factors of the last term are going to add up to give me the middle term. And then that's going to be the values that go here and here. So 36, 9 times 4 is 36, 9 plus 4 is 13. So this binomial, these two binomials of x plus 9 and x plus 4 are going to give me, are my factored quadratic of x squared plus 13x plus 36. Now if I wanted to check my answer, what I could do is I could always multiply this. I could use distributive property, do x times 4, 9 times x, 9 times 4. And that should simplify to this. Okay, so for this one right here, so again, same idea. And this down here, you guys, this is your formula for it, okay? This is just writing out those rules to show if I ever want to factor out a quadratic, okay, I need to figure out this p and q here, the terms that are being added in the quadratic, they have to equal, p times q has to equal c, so that means these are factors of c. And then if I add up these two values, it has to equal this number right here. So this is just the formula. So doing this one, I'm looking at what are factors of 28 that are going to add up to 11. Well, the factors of 28 that add up to 11 are 7 and 4. So that means I'm going to get x plus 7, x plus 4. And I'm done. Because 7 times 4 is 28, 7 plus 4 is 11, so when I multiply this out, this is going to give me this value. So the factored version of this is this. So go ahead and try this one on your own. Now we have a negative, so these negatives do come into play. So I'm looking at what are the factors of 18 that are going to add up to make negative 11. So with positives and negatives, our rules still apply. I'm looking at factors of positive 18 that are going to equal negative 11. So try it on your own and see how you do. So if I want two factors of a positive number to make a negative number, they have to be negatives. Because if I'm looking at factors of 18, well, I know 9 and 2 make 18, and 9 plus 2 is 11, but positive 9 plus positive 2 is not negative 11, it's positive 11. So that's why it's going to have to be negative 9 and negative 2. If I look at this, negative 9 times negative 2 is positive 18. Negative 9 plus negative 2 is negative 11. So I'm all done. There's my final factored answer. So negative 9 and negative 2 are factors of 18 that add up to negative 11. All right. Sorry, the pen's working, it's not working. So sometimes you're going to have ones that look like this. So if I have something that looks like this, so right now I don't have a quadratic. This is not a quadratic because this is x to the third power. So whatever we just talked about, our rules don't apply here. So what I need to do, but if I look, I have an x in common in all of these. So I can factor out an x first, because that's the greatest common factor. And then I can rewrite it. So if I factor out an x, now I can factor out this particular quadratic. So what I did here, because this isn't a quadratic, this is cubic, I factored out my greatest common factor. I factored out an x. Now I have a quadratic in here. I can factor just this out, and I can keep this x on the outside. So I pulled out the x from the original term, and then now I can factor out this quadratic. So I can look up factors of negative 48 that are going to add up to positive 2. So because it's factors of negative 48, I have to have a positive and a negative. And then that positive and negative have to add up to make positive 2. So this is where it takes a little bit more time. So if I look up factors of 48, I know I got 12 and 4. Well, 12 and 4 are going to make 8 if I have one positive and one negative, right? Doesn't matter, it will be negative 8 or positive 8, but 12 and 4 make 8, because now you're just finding the difference of them. So 12 and 4 do not work. I have 6 and 8. Okay, 6 times 8 is 48, and if I find the difference between 6 and 8, I will get 2. Okay, because whenever we combine positives and negatives, we always are really subtracting. So 8 minus 6 is 2. So because I need it to be positive, I need my 8 to be positive and my 6 to be negative. So there's my factors. X minus 6, x plus 8. Now, it does not matter, and the x stays on the outside here. It does not matter where you write the minus 6 or the plus 8. As long as I have plus 8 in one of these and minus 6 in the other one, I'm good to go. So the order in which you write these does not matter. Negative 6 plus negative 8 does make positive 2. Negative 6 times 8 does make negative 48. And then I still have that x on the outside that I factored out originally. So there's my final factored form. Okay. So sometimes you're going to have multiple variables. You're going to have x's and you're going to have y's. Okay, so it's going to be the exact same process, except for we're just kind of throwing a y on at the end. So if I look here, again, I can kind of show my example here. If I have x squared, and sometimes, sorry guys, the pen is just being really weird right now. This is not working. Okay, so if I multiply x times x, that's going to give me x squared. X times 4y. That's going to give me 4xy. 2y times x, that's going to give me 2xy. and then I have 2y times 4y. Well, that's going to give me 8y squared. So notice how this is the expanded form of it, right, when I distribute a property. But notice I'm still looking at what are the factors of 8, 2, and 4 that add up to 6. And then because I have the y squared on the end and the y included, it just means my last term is going to have a y on it as well. So the process doesn't actually change. So go ahead and try to factor this one on your own and see how you do. So see if you can do this one on your own, pause it, try it, see what happens. Okay, so this one, I just know it's going to be, there's going to be an x. Everything's positive, so I know it's going to be positive. I know I'm going to have a y here on the end, okay, because I have the y squared. So that's fine. So now I still got to do the same process. What factors of 24 add up to 10, and that's 6 and 4. And I'm done. 6 times 4 is 24. 6 plus 4 is 10. I have my y's, I have my x's. All is good. Nothing else to it. Okay. So a parallelogram has an area of x squared plus 9x minus 36. What are the expressions for the length and width of a parallelogram? So to find the area of a parallelogram, you just do length times height. Okay. And if x is an integer, what is the least possible value for x for the parallelogram to exist? Explain. So first what I want you to do is, let's do part A on your own. Find the length and the width of the parallelogram by factoring. So pause it and try it and see how you do. Okay, so factoring this out, I should have had factors of 36 add up to 9. Well, that's going to be 12 and 3. And a 12 has to be positive, and 3 has to be negative. The reason why is 12, positive 12, and negative 3 make positive 9. So there's my factored form. So those are the length and the width. Now it's saying if x is an integer, what is the least possible value for x for the parallelogram to exist? So if we know we have to multiply these to get the area of the parallelogram, what we have to look at, is it possible for our length and our width to equal 0? And the answer is no. We can't have a length of 0. We can't have a width of 0 because that means it wouldn't be there. We also can't have a negative number. So basically it's asking you, what is the least possible value for x to make sure that we have a positive number in both of these? Like if I put x is equal to 3, 3 would give me 0 here. Well, 0 wouldn't work. But 3 would also keep this positive right here. So it has to be anything greater than 3. So the least possible value would be 4. Because if I plugged in 4 for x here, that'd be 4 plus 12. Let me see, my pen's not working, so I'm trying to use a mouse. That's why it looks weird. I don't know why it's not working. That's 4 plus 12, and that's 4 minus 3. And that's the smallest integer because that's going to give me 1 for one side, and that'll give me 4 plus 12, which is 16 for the other side. They're both positive. If I had picked anything that was greater, if I picked 12 or anything less than 12, that would have made this negative. But then also if I had picked something 12, if I picked anything less than 12, that would have made this negative, so it wouldn't have worked. Okay, so that's why I had to make sure that this stayed positive and this one stayed positive, which is why 4. All right, that's all we got. Okay, so make sure we get the independent practice done. This does take a little bit of practice. Okay, and then that's all I got for you guys. If you guys have any questions, let me know. Thank you for watching. Gradius out.